Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, we're getting into similarity exercise 15D. 15D, there are two important things about this exercise. The first one, this is the main crux of the entire topic because this is where you understand where similarity is applied in real life. So basically, let's say a small version or miniature has been created into a real version, or a real version monument being created into a miniature. How does these conversions happen within their heights, distances and the length? This is the exercise about it. But the second thing is that for this year, that is 2020-21, so the people who are going to appear for the exam in 2021, they don't have this exercise is cancelled for them, but still I'm doing it just in case if you're curious to know why is this exercise and how is it helpful for us to understand from the point of view of the entire topic similarity itself. I am doing this exercise for all those people, so please pay attention. This is one of the most favorite exercise for me and close to my heart. Okay, now here what will happen is there is something called as scale factor. So there are four main things you need to remember. If you know these four things, you are sorted. So the first one is scale factor for the length of a particular dimension. The second one, scale factor for area. The third one is for volume, and the fourth one is conversion. So if you know these four things, you are sorted. So whenever they ask you the length, you take the scale factor as it is. Whenever they ask you area, you take the scale factor and you square it, because your area is always centimeter square, meter square or kilometer square, something like that. Likewise, use the same logic and tell me what will happen for the volume. Superb, that will be cube, because you have centimeter cube, meter cube or kilometer cube. That's basically what you have for volume. And conversion, so 1 kilometer is equal to 1000 meters and 1 meter is equal to 100 centimeters. So let's say if you want to convert 1 kilometer into centimeter, so you will multiply 1 by 1000 into 100 both together. So that will give you 10, 3 zeros and 2 more zeros. So that will give you 1 lakh centimeters. So 1 kilometer, 1 lakh centimeters. So you should know this conversion, most important. And secondly, you should know that whenever length is there, take as it is, area, square, volume, cube. Will you remember these three things? If you remember these four things majorly, you are sorted with the entire topic. Always remember what you are writing in the numerator, what you are writing in the denominator. If in the numerator you are writing a bigger term, write the bigger term on the other and RHS also. Likewise for the LHS also. So you got to see that carefully. Once we do the sum, I will explain what I am trying to tell you over here. So sum number 1, they say there is a triangle ABC which has been scaled up 2.5 times. So 2.5 times it has grown. Alright. So AB turns to A dash B dash as 6. So what will this be? Right. So what I generally do is I write scale factor AB upon A dash B dash. Now which is bigger out of these two, AB or A dash B dash? A dash B dash, because this has been scaled up. So write this also as 1 upon 2.5, because 1 is small, 2.5 is big. So here if the denominator is a bigger number, here also the denominator should be bigger. That's the basic rule. So AB we don't know, we are trying to find, and A dash B dash is given to you as 6. So cross multiply AB, I will get 6 by 2.5, or I can say 60 by 25. So 5 5s are 12s are. So my answer should be 2.4 centimeters. This is what AB will be. Now use the same logic. This time they say AC is 4. How much will be A dash C dash? Remember whatever you're writing on top. Now my thumb rule is always write the smaller, that is model on top and the monument down. So likewise scale factor always 1 upon something you will get. If you follow this thumb rule throughout this exercise, it's going to be very simple. Okay. So again scale factor AC A dash C dash. So 1 by 2.5, AC is 4 and A dash C dash we are trying to find. So obviously I am going to cross multiply and I will get it as 10 centimeters. So this is how the scaling up happens. So for example, if you have a monument like Taj Mahal and you're scaling down, or even for that matter in your geography, every map has a scale over there down, 1 is to 2,50,000 or something like that. That means anything on the ground which is 2,50,000, On the map it will be only 1 unit. That means on the ground, real ground, let's say the distance is 2.5 kilometers, then over here it will be just 1 centimeter. So this tells you what is the scaling that is happening, and that's why this topic is very important, because it talks about the real application of similarity. Let's take one more sum, and that will help you to understand things very clearly. They say ABC has been scaled by 3 on a point O. So you can either draw on the other side or the same side. So I have drawn it on the same side as A dash, B dash, C dash. So this particular point has 3 names: ABC, A dash, B dash, C dash, and point O also. Okay. So now how the scaling has happened is 3 times. Alright. Now 3 is what? AB or A dash, B dash? A dash, B dash, because that is bigger and AB is smaller. So you will write this as 1 by 3, the scale factor. Don't forget that. Okay. So let's hit the first part. Scale factor AB upon A dash, B dash, because that is bigger. So 1 by 3, and AB is unknown. A dash, B dash is unknown. AB is 4, A dash, B dash is unknown for us. So therefore when you cross multiply, your A dash, B dash will be 12 centimeters. Yeah. Can you apply the same logic and get me the second one? So scale factor, BC the smaller on top, the larger at the bottom. So 1/3. BC is unknown and B dash, C dash is 15. So 3 ones are 5s are. So I can therefore say BC is going to be 5 centimeters. Clear everyone? Are you getting a hand on this slightly at least now? Good. Third part, come on your own. Pause the video completely. On your own try it. OA and OA dash. So OA dash the bigger one. So 1/3. OA is unknown, but OA dash is 6. 1s are 3s are. So therefore I can say OA becomes 2 centimeters, and I get my third part. Fourth part, OC. Same logic. Scale factor OC dash. So 1/3. OC is 21 and OC dash is unknown. So 63 centimeters. Easy. Fifth part, OB dash upon OB. Now OB dash is up in the numerator and OB is down. So this is bigger, obviously by 3 parts. So you don't need to find the values. I can directly say 3 by 1, because I know that the ratio between OB and OB dash is 3:1, and OB dash is in the numerator, so 3 goes on top. Likewise on your own, sixth part, C dash A dash upon CA. So C dash A dash is 3, this is 1. So 3 by 1 again. You don't need to find the values for these 2 parts. You can do them directly, because you know that the scale factor is 3. Getting it now? Super. Let's take one more sum. I am 100% sure from 4th onwards you will get a better hand on this. Okay. Right now we are just doing on the first part, that is the length. If you remember right in the start I told you, just the length we are trying to understand. Gradually now we'll get into area, volume and the conversion. Yep. So you need to know all of them. Scale factor 1 by 400, so denominator is a bigger number. Model obviously numerator, real aeroplane. So aeroplane is 40 meters, how big will be the model? So you're trying to make a model and merge it, or you're trying to make a smaller miniature. So when you're making a miniature, you're reducing the real 40 meters to some extent. And in such a way you're reducing that everything reduces by the same scale, 1:400. So the real window of the aeroplane, likewise small window of the model will reduce by the same scale. So if everything is reduced by the same scale, your model will look exactly like the real aeroplane. That's why this topic is important. Let's come back. So scale factor, length of model upon length of aeroplane. So my scale factor is 1 by 400. Length of model I am trying to find, and length of aeroplane is 40 meters. So cross multiply, I will get length of model 40 by 400. Now this is in meters, but they want answer in centimeters. So meters converted to centimeters, so into 100. Therefore I will say length of model 10 centimeters. So the real aeroplane is 40 meters, but the model we are reducing it down only to 10 centimeters. Likewise, can you try the second one? This time length of aeroplane is asked in meters and model is given in centimeters. So now they are building you one step higher. Length only, but with conversion. Okay. So again, scale factor, length of model upon length of aeroplane. So scale factor 1 by 400. Length of model we don't know. but length of aeroplane is 16 centimeters. Oh, I messed up. Length of model is 16 centimeter and length of aeroplane we are trying to find. So cross multiply length of aeroplane 16 into 400, but this is centimeters. So divide by 100. So therefore length of aeroplane 16 fours are 64 meters. See, now use rationality. 40 meters comes down to 10. So 16 centimeters is bigger than this. So obviously the length also will be more than 40, that is 64. Are you understanding the rationality? Great. If you understand the rationality, you use a rational mind, you will get most of the sums here. Now sum number 5. I want everyone to try this one. Come on. The model is given for a building. How you go for construction sites and you see those smaller buildings out over there? Yeah, in our school also we made that, and children only made that using this topic, using this concept. That was 3 years back. Pashwa Zaveri was the captain. Anyways, let's come back. So building, the length, breadth and the height of the model is given. What will be the real length, breadth, height is what you have to find, and scale factor is 1:30. 30 is bigger in the denominator, so actual also will be in the denominator. So scale factor, length of model upon length of building. So 1/30, length of model 1.2, so length of building, cross multiply, I will get length of building as 36 meters. So a model 1.2 meters, in real building it becomes 36 meters. Can you find the second part? This is the first. Now for the breadth. So again scale factor, breadth of model upon breadth of building. Come on, try it out. Pause at least now and get me breadth and height and only then come back. Okay. So 1/30, breadth of model 75 centimeters. Okay, don't forget that. Into upon building. So therefore breadth of building 75 into 30 centimeters. So converted to meters. 0 goes away. 5 15s are 5 2s are. It becomes 45/2. So 22.5 meters. And then the last part, the height. So scale factor, height of model upon height of building. So 1/30, height of model. Height of model how much? 2 meters upon height of building. This is comparatively easier. So therefore height of building becomes 60 meters. So we found the length, we found the breadth, and we found the height of the real building. Was that the only thing to be found? Yes. Actual dimensions of the building, that is length, breadth and height. How many got this on their own? Great job. If you're getting it, I'm impressed. 7th. 6th one I'm not doing purposely. You must try something on your own, isn't it? Come on, 7th one. Again, this is a model and a ship, and here they have given you area, volume, length, everything. Conversion might not be there, so you are safe with the 4th part yet. So scale factor, length of model upon length of ship. So the scale factor is 1/300. Length of model 2 meters. Simple this is. So first one I'm sure most of you all will get. So length of ship 600 meters. My God, what a giant ship this must be. 600 meters, isn't it? Yeah. The next part, first part gone. Second, now area. So scale factor, area of model upon area of ship. Where is my mistake here? Model area, ship area. Area means square. Don't forget that. And don't square this part. I have seen people squaring the RHS. Square scale factor. Don't forget that. So 1/300, the whole square. Area of model is not given, but area of ship is given, which is 1,80,000. So area of model 1,80,000 goes up and 300 stays down twice, once and twice. 1 2 3 4 cancel. 3 ones are 6 are, 1s are 2s are. So therefore area of model, it's a small model, and therefore the area also isn't too big, 2 meter square, because it is area. Now for the last part, the volume. Can you try volume on your own? Let's become little adventurous and try things on our own. Let's see if you can tackle it. Come on, get me the volume. So the third part, scale factor, volume of model upon volume of ship. But scale factor gets cubed this time. Okay. So 1 by 300, the whole cube. Volume of model 6.5 upon volume of ship. So volume of ship 6.5 into 300 into 300 into 300. No conversion because everything is in meters. So 27 into 65 is what I will have to multiply. So I am taking a rough sheet. 27 into 65. 6 5 are 35, 10, 13, 42, 4, 12 plus 4, 16. So 5, 5, 7, 1. So 1, 7, 5, 5. And 1, 2, 3, 4, 5, 6. My God, 1, 2, 3, 4, 5, 6. So many zeros. So here, here, and here. And one decimal. Oh, so this 0 is going to go off. Yeah, so 1, 2, yeah, correct commas I put. Meter cube. 1755 and then 5 zeros, meter cube. Got it? How many of you have got this correct? If you got the third one correct, brilliant, you are on track. Let's take two more questions. This is from the next exercise 15E based on model. Only two sums from that exercise. So I thought let me finish them with this video itself. So here, you've been given in sum number 18 that on a map drawn to scale 1 to 20,000. This is your proper map, okay? A rectangular plot of land ABCD has AB 24 cm, BC 32 cm. Calculate the diagonal of the plot in kilometers. So diagonal they want, but not of this, the map name, the real plot itself. And then finally area of the plot also. So you have two choices. First find the diagonal here and then convert the diagonal with scale factor, or convert AB and BC as per scale factor. Whatever answer you get, that you take Pythagoras and then get the diagonal original, right? For me, I think I will get the diagonal and then I'll convert the diagonal. That is easier, okay? So let's apply Pythagoras in triangles ABC. Angle B 90 degree and therefore AB square, that is 24, plus BC, that is 32, equals to AC, Pythagoras theorem. So 576, this is going to be 1000 something, 4, 3 to the 6 to the 12, 9 and 1, 10, 1024 is AC square. So AC is root of 1600 and therefore I will get AC as 40 centimeters. So I have got the diagonal in the map, but I need to find the real diagonal. So now scale factor, diagonal AC map and diagonal AC plot. That is the real plot we are talking about, okay? So scale factor 1 by 20,000. On the map it is 40 centimeters. You'll have to convert also. So real diagonal AC. So real diagonal AC 40 into 20,000. But since this is in centimeters, converting to meters, so divided by 1000. So 1, 2, 3. Okay, converting to kilometers. So centimeter to meter first and meter to that, okay? So first meter will be 100 and then meter to kilometer is 1000. So you'll have so many zeros. So 1, 2, 3 cancel, 1 cancel, 1 more cancel. So 4 2s are 8. So therefore diagonal AC is 8 kilometers. My God. So real plot has 8 kilometers as the diagonal. Are you getting this? The first part, the diagonal. Now the area of the plot. Or to get the area of the plot, two methods again. Get real AB, real BC and then multiply. Or get the area of this model and then convert using the scale factor. I will use the second method. So area of model is going to be length into breadth. So 24 into 32, let me multiply on a rough sheet. 24 into 32. So 4 2s are 8, 2 2s are 4, 4 3s are 12, 6 and 1 7. So 8, 6, 768. So I get 768 centimeter square. Now you are going to convert centimeters also. So scale factor square, area of model upon area of plot. So scale factor 1 by 20,000, the whole square. model 768 upon area of plot, and this is in centimeter square. Now you got to be very careful here, making no mistakes. 768 into 20,000 into 20,000 upon, now this is centimeter converting to meter, converting to kilometer. Since it is area, your conversion will happen twice. If it was volume, you would have converted thrice. So one more time, meter, centimeter. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. So 100 is left. I'll have to multiply all this. So 2 2s are 4, 4 8s are 32, 427, 30 divided by 100. So my answer is going to be 30.72 kilometer square. This is your real model, real plot ka area. Did you get it now? Interesting. This last part is very interesting. That's why I picked these two sums, so that you get proper and thorough practice on this. Okay. Alright. Sum number 19, the last sum in exercise E. Come on, try on your own the last one on your own. They say that there is a building with model so and so dimensions. Find the real building dimensions, scale factor 1:50. Then area and volume. So everything given, even conversions also given. So nothing is left. All 4 parts that I taught you in the start in one sum. Usually such type of sums come in the board exam. But this year, for 2020-21, you guys are not going to get this exercise. But after that, yes. So first part, scale factor, length of model upon length of building. So scale factor 1/50, length of model is 1 meter upon length of building. So this was pretty simple. Length of building straight away becomes 50 meters, because this is 1 meter, so no conversion required right now. I at least managed to get the length of the building straight away. Now let's get the breadth of the building. So that was the first part. Second, no, this is still like that only. So scale factor, breadth of model upon breadth of building. So scale factor 1/50, breadth of model 60 centimeters. Okay, don't forget that. Breadth of building. So you will say, therefore, breadth of building 60 into 50 converted to meters, so 100, 0 goes away, 30 meters. That's your second part, breadth of building. Yeah. Now the third part, again scale factor, height of model upon height of building. Come on, pause, at least get this third part on your own. So 1.20 is given and scale is 1/50. So 1.20 upon height of building. No conversion required because already in meters. So height of building, 5 12s are 60 and 2 zeros, 2 decimals nullified. So 60 meters. So we managed to get the length, breadth and the height of the building. Now area is what you need to work upon. Okay. So let's take the next sheet and work on the area. Everyone. So area of the model. This is part 1 now. So scale factor, since it's area, you square it. Area of model upon area of building. So scale factor 1/50, the whole square. Area of model 50 centimeters square. So remember to convert, don't forget that. Building. So area of building will be 50 into 50 into 50 centimeter converted to meter, converted to meter. Yeah, even if you keep in centimeters, since they have not asked you to convert, they will consider. But my advice is better you convert. So 0 0 0 0 0 goes away. 5 1s are 5 2s are. So 25/2, that becomes 12.5 square meters as your area of building. How many got the same answer? Super. Now for the volume, and volume of building is given to you. So if volume is asked, what are you going to do? Scale factor will get cube. Volume of model upon volume of building. So scale factor 1/50, the whole cube. Volume of model, how much is that? Not known. Building is 90 and that too meters. So volume of model not known. Building is 90 meter. So we can convert this So into 90 upon 50, 50, 50. So convert the meter to centimeter 3 times, okay, volume. So 1, 2 and 3. Your answer is volume of model. So let's see what do we get. 1s are 2s are 1s are 2s are 1s are 2s are 8 into 972. So therefore volume of model 720 centimeter cube. Write your units correctly. So all in all, in the entire exercise, if you notice, we did only 4 things, nothing else. First, the normal length, which we did here, right? Only scale factor. Second, the area. So when area is given, scale factor becomes square. Third, the volume. When volume is given, scale factor becomes cube. And fourth, the conversions. If you know these 4 things, you are sorted with this exercise. No need to worry at all. For your homework, I want you to do exercise 15D 2 and 6, 15E 19. You must take this as if it's a part of your syllabus. Please don't ignore it. That's my advice. Ultimately, it's your call. Alright? Until the next video, when I take the last exercise of similarity, take care, stay safe, pray for everyone, and be honest. Bye.
Hope you had a lovely mathematics experience with the rough book, our learning companion.